All right. Well, I maybe we'll get started really quickly and then we'll kind of go through our presentation. This is part of the STEM Forward Spring Educator Forum. We're delighted to be here. This is our first time. We're going to be talking about robotics, and you'll get a chance to try out the CoderZ platform. And so I am Cheryl Moeller, I'm the one speaking right now. And Jeannie Badger is with me today. And my past background prior to doing what I do now is I was an electrical engineer for about 7 years in the semiconductor industry. But I've been working in informal STEM education since 2004. I've had a variety of different experiences, learned a lot about education at the Botkin Museum, and I've taught at University of St. Thomas Steps Camp. And I've done some freelancing under the name STEM Ahead. So a little bit of my own experience, my coding experience in college was not all that pleasant. In fact, I kind of gravitated very quickly to the hardware end of things, but I feel that computer science is such an important future to what our industry has gone to and what the technical jobs that are available. And so kind of steered my own kids in that direction. And I have 3 adult children who now are working in the computer science field. And Jeannie, did you want to just pipe in and share your introduction of yourself?
Sure. So my name is Jeannie Badger, and I have been with High Tech Kids for, I think it's 6 years now. But my children, I have 3 boys. They were actually involved in the programs through High Tech Kids, the first programs that Cheryl will talk about in a little bit. I actually am not a coder by trade, and I'm not a teacher. I fell in love with the programming along with my kids. And so one of the things I like is learning to code kind of on my own. And Cheryl has in here that I am a tutorial lover. I love following the directions. And it's one of the things I love about one of the programs that we offer, the CoderZ, is that you don't have to have that STEM-based knowledge. It's kind of all in the package for you to kind of walk you through it. So go ahead, Cheryl.
Great. So we'll move on to who High Tech Kids is. We were formed under the name Innovations in Science Technology Education, sometimes called Insight, which is a mouthful, and very quickly moved on to the name High Tech Kids. Our founder was an engineer, and he just fell in love with this First Lego League program and actually helped develop with FIRST, and I'll talk about FIRST in a minute. So we are a program delivery partner for First Lego League Explore, First Lego League Challenge, First Tech Challenge, and CoderZ in Minnesota. We're a staff of 5, and we coordinate all the events, the tournaments, coaches training, professional development for teachers, all the registration process. We do a lot of research workshops, programming workshops, and then we recruit and train a lot of volunteers, about 300 event volunteers, and coordinate our state championship events. So we do a lot with our staff of 5. This year was a little bit of a change from past years because of COVID, and we did have a huge reduction in our number of teams, but we still did serve quite a few students. It was probably about 4,000 students that we did serve this year. So it wasn't, it was still quite a bit of effort, and we transferred everything to a virtual online platform. I mentioned FIRST earlier, and they are the global nonprofit, which is an acronym, which stands for Inspiration and Recognition in Science and Technology. They're based in New Hampshire. They have 4 programs that are international. First Lego League Explore, First Lego League Challenge, First Tech Challenge, and then First Robotics Competition. And that last one, First Robotics Competition, we do not organize those events. However, we do partner with a lot of their teams in hosting our events. And that program itself is run by FIRST out of New Hampshire. And of course, everyone's heard of Lego. Lego actually makes a lot of the products that we use in our First Lego League programs. So a little bit about the age frames for these programs, so you know what I'm talking about. The First Lego League Explore, that used to be called Junior, so if I say the wrong name, that's the same program. 6 to 9-year-olds, teams of 2 to 6 kids, and this program has grown pretty rapidly for us before COVID. So it's a little bit less of a time commitment. It's not really meant to be a whole year program. It's probably meant to be a 6 to 12-week program if you're meeting once or twice a week. Our largest program is First Lego League Challenge for 9 to 14-year-olds. This is a large program at High Tech Kids. We're one of the largest partners in the world. Teams of up to 10 kids. Pre-COVID, we had 640 teams, which is about 4,000 student or 4,500 students participating. And I'll talk about the specifics of what each program does in a later slide. And then First Tech Challenge is a program for middle school through high schoolers, 7th through 12th grade, teams up to 15 kids. We had about 212 teams. And this past year we had 104. So we just saw a 50% reduction in those teams. So I'm going to share a little bit of information about each program. And on these slides here, First Lego League Explore is the program for the little kids. They build a Lego diorama, kind of a model using the Lego We Do, and they learn actually how to program that using some graphical programming language, which is really easy for kids. They jump on it and figure it out right away. They also do some research on a global challenge, and that global challenge theme changes every year. And next year, it's going to be learning about transportation. So if you do sign up to coach a team, there is a lesson plans included. It's really nice for the coaches because they're kind of provided with a curriculum just to kind of walk through. Kids learn a lot. They learn about a theme different every year. And as I mentioned before, the themes do change. They learn how to create a poster describing what their team did and what they learned about the theme, and then actually do some building and a little bit of programming. And we hope that all the teams can celebrate their work at one of our expos. It's optional, so they could share their work at school or at a library or something, but we have some fun activities planned for them if they decide to participate in an expo. All right, next I'm going to go on to the First Lego League Challenge program. So on this program, they're going to build a robot to compete in a gym that's loud and crazy with probably some loud music to complete some missions. And they have as much, they can complete as many missions as they can in 2.5 minutes, which seems not very long, but they can actually do quite a bit with programming. It's all autonomous. So all the robots program, they just hit go. They're also going to research a real world problem, and they're going to present their findings during a judging session. And we have some core values that I'll share in a minute. And we really expect all teams to compete in one of our tournaments. So I mentioned before that they're going to learn how to program in one of the versions of a Lego robot. Any version of a Lego robot that's ever been allowed is still allowed. And then Lego comes out with new ones probably every 5 years or so. And the newest one is called Spike Prime. This theme is called Cargo Connect, and they're going to be learning about how to transport people and goods. I heard Amazon's a sponsor, so I think moving things, and they're kind of the experts at that. Kids are going to learn some of the innovations that happen with that. And our work is kind of shared in a sports-like atmosphere. It's meant to be fun and inspiring to get kids to kind of get hooked onto STEM and return the next year. And teams are judged in different aspects of it. Their project they worked on, their teamwork, their programming, how they designed their robot, and of course, how well the robot solved the missions. I mentioned a little bit about this robot game. The teams actually, there's more missions than they can actually accomplish in 2.5 minutes, so they have to strategize and prioritize. They get to build arms and tools, so like attachments to put to the robot, and they really want it to be reliable and repeatable. And this really teaches the concept of testing and reinventing. So you design it, then you test it, then you make improvements and you try it again. So, and the competition floor is fun. We're going to show a video in a moment that you can kind of see what that looks like in a second. So the research project I mentioned the themes change every year. We've studied everything from nanotechnology to medical devices. One year we did Nature's Fury, which is about natural disasters. One year we did one on animals, and it was all about trying to develop something to make life a little bit easier for an animal. And this next theme, I don't know the specific research question, but it's going to be on transportation. So the kids do need to research the problem, figure out what some of the challenges are, and then they have to come up with an innovative solution. And kids come up with some fantastic ideas. I think they teach adults a little bit how to innovate and how to think outside of the box. And then we hope that they'll use their own creativity to design a solution and share that back in a skit, perhaps some fun way. And then we'll have a panel of judges look at their results at one of our tournaments. Core values. All of the FIRST programs actually operate under one set of core values. So this would be First Lego League Explore, First Lego League Challenge, and First Tech Challenge. And these are the concepts that FIRST is what the team will do and how they do it. So we want kids to discover new things, to learn new skills and ideas, to innovate. I mean, you get better at innovating when you have more experiences at it. So using creativity and persistence, I think, is a great thing to learn to actually solve problems. Impact, First Leg program is great to show what they learn is how they can improve their own world. We've seen a lot when we did a trash theme one year. Kids really implemented some solutions even at their cities on how to improve how trash was collected or how parks were picked up, and they can have an impact even as a 9-year-old. Inclusion, we respect each other and embrace our differences. Teamwork, we are stronger when we work together, and fun, and we enjoy and celebrate what we do. First Tech Challenge is for our students in grades 7 through 12. Our teams actually have the option to play in 2 qualifiers for this program. Kids put in a lot of work to build these robots, and we want them to have as much experience and iteration as possible. And so they actually create and program a robot. They can use a kit of parts, or they can create their own. They will work collaboratively to design a strategy with their team, and they adhere to the same values I mentioned before, and they hopefully compete in one of our events. The kids actually are programming Android phones to control the robot, but we have a really strong partnership with Stratasys, which makes 3D printers and also has been willing to 3D print parts for teams. So kids can learn 3D printing in CAD by printing their own parts. Students on the team will learn to program in Java. That's the programming language we use. And teams are judged not only on their robot and how that works, but on their STEM outreach to the engineering and education community. And kids really do get to improve their presentation skills, especially when they work with other engineers. A little bit on the timeline, and this is actually similar to the CoderZ program that we're going to talk about in a moment, but May is when our registration opens up with the first team registration. We should have all our information on our team scholarships open up in June. The challenges for First Leg League are released in August, and First Tech Challenge, they released in September. And one thing I will want to say is if someone wants to participate next year, they shouldn't really wait to September to start looking into it. Now's the time to kind of do some research, perhaps figure out, who's going to coach the team, how we're going to pay for it. And the more you can know before September hits, the better off. The rest of the world kind of starts their schooling in August, and we start in September, later than most of the country, and we have a pretty early tournament registration deadline, so we kind of need teams to be formed by the end of September so that they are ready to compete. Teams meet September through February, build their robot and iterate, and our season kind of ends at the end of February with our state championships. And then the World Championships for the top 1% of the teams are held in April. And with this, I'm going to downsize my video here, and I'm going to show a video about the program that we have. So just hold on just a second while I pull that up. Right here.
To compete in a global challenge has allowed me to find a community of like-minded individuals with whom I can have a greater impact beyond the classroom. Seriously, our first team is like running a small business. I lead a team of 15 students, which has taught me a lot about myself, provided me with internships and real-world opportunities I had no idea existed, and given me access to scholarships that I thought were only accessible to athletes and geniuses. I can't stress enough that FIRST isn't just for future scientists and engineers. I'm genuinely excited to take what I learned from FIRST, the technical STEM skills and self-confidence, collaboration, and leadership, and apply it to the next chapter of my life as I prepare for medical school. FIRST has really shown me the value of experiential learning and made me more confident than I've ever been. Now that my school district has expanded FIRST programs to all ages, I'm glad I can give back to the kids in my community who are starting right now with First Leg League. Once you're in it, you're a member of FIRST for life.
smartphone is so smart. It raises and lowers using a hydraulic-powered scissor lift system and transmitters placed in residents' cars. Neighborhood residents wouldn't even notice it. It also lowers for emergency vehicles, the same way that lights turn green for them.
It might be an option to switch these cords to see if it's the circle. Although that would require breaking.
It's fun to see how First through the years develops this interesting network of people. Both of my kids. Hi, I'm Heidi Sipe, Umatilla School District Superintendent and First Robotics Coach. First has been a game changer for our school and our community. It's helped us change culture and, more importantly, change the trajectory for our at-risk students. First exposes students to different professionals and to top universities across the nation to help them want more and to see more. First has helped our students attend great universities and become part of STEM professions all across the nation.
Yes, we build robots, but we also want to have a bigger impact in our society.
First for us starts at kindergarten and goes through high school, and it's exciting to see our high school students helping our younger First students succeed. I have seen firsthand the absolutely positive impact that First has had on our school culture, and I want that opportunity for every student in America, and I'm counting on you to bring First to your school and your community, because First works for students.
All right, I think I need to stop the video just a second here. Might just keep playing here. There we go. Here. I want to go back to this slideshow. I'm really happy to show that that part of that footage was filmed at our state championship in Minnesota. So the second part of the video was with the First Tech Challenge. So we were really honored to be chosen for that. But our first LEGO League events looks very similar to the Colorado footage that was filmed. Head back to our presentation here. Let's see. Share screen. All right, Jeannie, I'm going to have you take it from here.
Okay, thank you, Cheryl. So Cheryl talked about the first programs that we sponsor, and another program that we've just taken on, actually, we'll be starting our second season. It's called CoderZ. And CoderZ is also, it's a robotics, but it's virtual robotics. So it kind of gives a little bit different component to it. So CoderZ is available in kind of two different programs. The CoderZ Leagues are competition-based programs. So it's a cyber robotics competition, and it's for kids in about teams of 5 or 6. And this is a program that they compete from starting in October and it goes through various stages, and then it culminates in this year, again, it'll be a virtual World Finals, and that will be in January. So that's pretty exciting. And like I said, Minnesota, we just had a few teams in 2019, 2020, when we first launched it. This slide's a little bit wrong. We actually had over 50 teams that participated. And then the 2021 season, we had even more. We actually had quite a few teams that opted not to do First Lego League and tried to do the CoderZ since they couldn't meet in person. The second aspect of it is the CoderZ curriculum, and this is a full-fledged curriculum, and I'll show a little bit about that in a video in a second. That's an annual license, and this is for, it can be used obviously in the classroom, the full-fledged curriculum, or we are finding that smaller robotics clubs or even individuals are offering the CoderZ curriculum to their kids. So for the main focus on this is mainly kids, 4th grade all the way up to 12th grade. I'm sure I'm gonna hit the. So with the league program, they just added, we're pretty excited, they added a 3rd tier to the league challenges. So there will actually be the novice league, which is kind of focused on the kids 4th through 5th grade. And then there will be a junior league, and that is for the kids from 5th through 8th grade. And then the CoderZ League Pro, and that is for the kids 7th to 12th grade. The programming is in Blockly, which is Scratch based. So the kids who are doing Scratch are very comfortable with that. And if they don't do Scratch yet, it's just kind of drag and drop the blocks. So it's very easy to use. What's kind of neat about it is that they can actually look under the hood, as we say, and they can see what their Blockly code would look like in Java. So though they're not programming in Java in the novice and the junior, they can see what it looks like. But then in the CoderZ League Pro, they can actually code in either Blockly or they could code in Python. And if they are coding in the Blockly, again, they can look under the hood, see what that Python looks like, and that kind of helps them and say, oh, I do know how to do this. And then they can translate that in and code in the Python. So they kind of build up on that. This is what the platform looks like when the kids get into it. And actually what we will be offering to anyone who logs in with this is we're going to give you about 2 weeks free access as a student. So you can go into the courses and walk through it like a student would and see what is available to them, what it looks like, how the tutorials work, how the students are guided through the program. Normally, if you were offering either the leagues or the curriculum, you would only have one class available to the students. What we are doing so that you can, for this demonstration, what we are doing is we're opening up all the programs so that you can kind of try it. If you have students in the lower level grades, you can try either the adventures or maybe the Cyber Robotics 101. If you have those older kids, you can try the Cyber Robotics 102 or the Advanced, the Pro, which is where they are learning the Python in the Python gym. And so the login that you will use will get you in, like I said, as a student. And then later on in this presentation, I will actually go back in and show you what the teacher side looks like. So you'll see that you don't have to be a programmer. You don't have to know all the ins and outs of the computer science. So if you are looking to add this to your school curriculum, this is so that you don't have to know everything in order to do it. The curriculum is fantastic the way it's layered in there and helps the teachers get through it. So, and this is just kind of a quick couple screenshots so you can kind of see what it looks like. And again, this is the Blockly programming. This is part of the Cyber Robotics 102 program. So they are using some of the advanced concepts. You can see over on the window, they're using the gyroscope, they're using the encoders, the color and ultrasonic sensors. So they are learning also, even though it's virtual, they're learning how to use the sensors to get around the virtual world. And then this is, like I said, peeking under the hood. So you're looking at it and you can see what the code would look like in the Java So again, they're not programming necessarily in the Java, but they are learning what that looks like underneath. And if they were doing the last component, the Python gym, which is for the 7th through 12th graders, they have the option of programming in either the Blockly or the Python. And this is one of the, I think this is one of the neat things. It's one of the things that the kids really like about either the leagues or the curriculum. So this is in the curriculum, you can actually have the leaderboard. So this is your classroom. You can set it up so the students can see how they're doing against the other students. And we know that the kids like that competition aspect. So even in the classroom, they can have some of that competition, and they're like, oh, Craig's done one more mission than I have. I'm going to stick around. One of the things that teachers tell us is that oftentimes they have to tell the kids, we're done. You have to stop for now. And they're like, no, just one more. I just want to do a little bit. The other things is this is all online. So it's available through any browser. So the kids can, if you give them permission, actually work on this from home. This is one of the reasons that when COVID sent so many kids home, a lot of the teachers were actually able to keep going with the robotics programs because they didn't have to have the hardware. The kids didn't need the physical robots to make things go. And they are all programming their own virtual robot. One of the nice things about it too, like I said earlier, I have 3 boys. The first thing my kids did is they drove these robots off the table. That's what they wanted to do. The nice thing is the robot is virtual, so it plunks back up and nothing is broken, so then they can keep going. And then the teachers don't have to spend a lot of time troubleshooting lost pieces, lost parts, bad connections, low batteries. Like I said, it's all online. So the kids just need to get on mainly through a Chrome browser is one of the best ways to do that. It works really nicely with Chrome. And then I'm going to show you a quick video, and then I will walk you through how to log into this. Share my screen.
The role of robotics continues to grow in how we live our lives. The role of robotics in education becomes increasingly important. This is
I can't see it.
A virtual robotics platform.
I can hear it though.
All right, let me try that one more time.
That's great.
As the role of robotics continues to grow in how we live our lives, the role of robotics in education becomes increasingly important. This is why CoderZ, a virtual robotics platform, is becoming the leading learning environment of choice for students and educators through online courses and exciting virtual robotics competitions, which empower students and develop their 21st century skills in ways they never thought possible. No expensive equipment or special teacher training background knowledge is required, making the most equitable and sustainable STEM and robotics education program in the world. School adoptions continue to surge. We've brought virtual robotics to hundreds of thousands of students directly and through our global partners, including Amazon and Lego. So partner with us to deliver to schools an inspiring and motivating STEM experience. Thank you, and may the code be with you.
Great. And then Cheryl, if you can just go ahead and share the screen again.
Okay, just give me a second. Let's see.
Okay.
Do you want me to be here or here?
On the screen showing the login information. Yep. All right. So what you can do, this will be shared out, and you can go to play.coderz.com. And there's 2 tabs, and you're going to click on the right tab, which is Join Class, and you'll need this class code. So the PMF1ZYJ5, that's the letter IA at the end. Entering that class code in, and then Cheryl, if you show the next screen, and then you'll come to this login, and you'll be told that you can invite, you can join Jeannie Badger's CoderZ class. Even if you've already seen CoderZ, don't log in with that account. If you're new, just click on that sign up, don't have an account, and sign up. And then Cheryl, I'm going to grab the screen again.
Okay.
And I'm going to walk you through mine. So what it will actually look like. You see on my screen?
I'm not seeing it yet.
All right, I have to. There we go. Sorry about that. Okay, so
Now
you
I see
come to the Go CoderZ screen. Like I said, click on that right tab, join a class, enter that class code. I'm going to have you log in and create a kind of even a silly username is fine. Don't use your Google login because if you do want to use the account for yourself at a later time or create an account, it gets kind of clunky and confusing. So I'm just going to create an account here, a Snoopy. The thing you do have to remember is your username and your password, and then it's going to say next. You'll just step through. For ease of use for any of the teachers that are looking at this, you want to tell us that you are at least 14 years old, and that way you don't have to kind of do the extra step of asking your parents permission to join. This is set up, and again, you can kind of tell me whatever information you want here. This is just mainly for
Jeannie, do you have the code handy?
I
I will have to. Carrie just
Sorry.
asked in the chat.
Oh, okay.
Is it?
I don't have it, Cheryl. I'm kind of out of my
Okay.
screen there. So if you can grab it, and we can certainly get
Yeah,
that
I can
in
get
the
it.
chat.
I'm gonna get it different. I'll put it in the.
One of the nice things is if your students are actually under 14, and this is in regards to the FERPA rules, they can participate. So you can log them in, invite them. So even before you have the parents' approval, the parents' authorization, the kids can start doing activities. But what will happen is you, the teacher, will not see their name on that side. But they can start doing things. You, the teacher, will actually see those as anonymous. It'll almost spin up a little bit. And then, like I said, I'm actually opening all these courses to you. Normally in your class, you would just have the one program. So the kids will actually just click on here, start going through their fantastic tutorials to kind of walk them through. And this is what you will be doing. You'll actually be a student in my class and trying things out. Accept that there. And it's because I've got Zoom open, it does take a little bit longer. Normally, when I'm just doing this and I don't have the Zoom open, it does not take as long. And again, I'm just going through my Chrome browser here to get into the actual CoderZ. And then I think one of the biggest kind of goofs is people keep going to that login and join a class. Once they've joined the class, they'll just use that password and username they set up. So I would use that Snoopy 222 and the password. And so actually, as soon as I'm in here, here are the tutorials kind of walk me through telling me what to do. So the drive block's not connected, and next, and I'm going to drag and drop this to fix. I'm going to run the code, and then you can see over here, and I'm actually, there's that code that I was talking about underneath. And then I can also make the screen bigger, and I can reset, and I can watch it again, running that code for me. Okay. Go. I can see. And then what's kind of fun about it is right away the kids kind of see that success. So they've got that success going right off the bat, and that will kind of walks you through. I can try it again, or I can just click on the next activity. So it's going to walk me through each of the steps. So my robot's facing the wrong way. Okay. And do two things. What's nice is initially only the blocks that I'm learning about are available to me. So I can't go in this big, long thing, see everything and feel overwhelmed. As a teacher, you can also kind of lock things down. The way I've got the class for you is everything is open, but you can actually set it up so only module by module is available to the students. And then I'm going to make that big again. And then you can say, oops, I obviously did something wrong. My robot is spinning. So I'm going to reset that. And then I'm going to look at and say, oh, what did I do wrong here? So what I can do is actually restart. And I like this because my instructions, because I wasn't paying attention or I was cruising through, it's going to walk me through and I don't lose those step-by-step instructions. My robots, I need to turn left or right before I've got it all. So yeah, because I was zooming ahead. All right, so now I'll try it. So I had to turn and then drive forward. Okay. So that if I'm done for the day, I can go back to the Learning Center. Again, as a teacher, you can lock this down so they don't have access to everything. But right now, as if I'm one of those students that likes to jump ahead, or we had some people in our office who were who were testing this out and they skipped ahead, which is fine because that's part of the learning too. But every lesson builds upon the information. So if you jump ahead, this may start talking about sensors and the kids haven't learned those, but that's okay because once they're in here, there are help modules as well. There are tips that they can use. And again, it's still walking through here. We're learning about geometry, learning about degrees and angles. And then there's the explore mode. I'll show that. But under here, so I can do my next activities, and then there are helps. The explore modules are here, and those going to pop up over here. And you can see how I can measure distances. I can look at the different angles. So again, depending on what grade level the students have, the information is there to help them out. So if we had any people in here right now, I was going to give you, 15, 20 minutes and actually let you kind of walk through and work through the systems. I'm not going to do that right now because that would just be, I could sit and play with this all day, but I'm not going to do that. But what I am going to do is I'm going to jump out of my classroom here. And again, that was looking at that as a student. And I'm going to log in as into my teacher account. And I will show you what is there for the teacher, because I think this is one of the best parts about CoderZ is it's showing you that you don't have to know everything. So that was the CoderZ adventure that I was working on. So you can see that's the novice, so that's for the younger kids. One of the best parts is right here, in my opinion. This is the teacher's guide. And it walks you through. So your teacher guide has, this is really your starting point. One of the best suggestions is to go through the lessons, right before before you're going to present to the kids. You can kind of freeform it, but what's here is pretty much what you need. The course description, the content, how much curriculum, talks about those gamified missions, the online knowledge base. This is such a fantastic thing, especially if those kids ask you that question that you just have no idea what the answer is. So you can just do the search. So we're going to look up how the gyro works. And here are all different sorts of resources that are here, how to use them, what parts are using it, how to configure it for your EV3 robot. So your knowledge base is there really to help you out. So again, if you are not a professional coder or in robotics, the information that you need is there to help you out. And Let me get back to my window here. So, and there's your coursework. They've got the outlines, the lessons are set up for you, so you can just follow along here. And again, you can open these up or lock them down as you needed. The session format, even giving you the pacing guidelines. And so which blocks you're going to use, what tools you're using. Like I said, the pacing guidelines. And again, all of these links are fantastic things that give you access to the resources that you need to be successful when you're working on these classes with the kids. So then your classes, so this is your classroom, you can have access to all the different classes. So if you have more than one, maybe hour that you're working on or different classrooms. So here's the STEM Forward Educator Forum. This is the class that you would be joining. So these are the heat maps. So as you're going through the activities, I can see who's in my class and which activities they've done. And this will populate, so different things. So Jeannie Snoopy, that was the one that I was just doing, has successfully completed these Just Drive programs. And then I can see if they've gone further in there. And so here Cheryl is part of my class. And the different colors mean different things. So again, green, she successfully completed the task. What the gray means is that Cheryl skipped over that one entirely, which again, might be okay. Maybe you told the students to skip that one. And then the pink tells me that Cheryl is working on that one. She doesn't have any points yet, but she has actually clicked on something. She's probably watched that initial tutorial video. So I can see what's going on in my class with the different students in there. This one, I can also see how long she's taking in there. So what's really kind of fun to see is that you have those kids that are zooming through, and then the kids that are struggling. Oftentimes you can look at this and say, okay, Cheryl's understanding this. She's doing a great job. I'm going to maybe let Cheryl be the mentor and maybe take the lead and take the opportunity to say, Cheryl, can you share with us how you solved that mission, what kind of things you did to have success with that. Another thing that I like, I know I say this is one of my favorite things, but I just love this program so much. So when I'm working on this, again, as the teacher, I don't have to know the answers. I don't have to know how to do it, because one of the things that the CoderZ has built in, and I'm just waiting for this, and again, it's a little bit slower because I also have the Zoom going on, is they actually have a coding sample for me. So I don't have to have the answers to have figured out how to make that robot successfully use that sensor, climb up the ramp, do whatever. So I can actually have a sample program, so I can actually show the kids, here is one solution. That sample program is not available to the students. That is only for the teachers. You can see in my window, here's the solution for me. And it's going to wipe out my previous solution, and that's fine. So here it is. So it's showing me. So when the kids are saying, oh, that one's impossible, it can't be done, I can actually run the program and show them, yeah, look, it's, here is one way of doing it. It's not the only way of doing it, but it is one way of doing that. And so I like that aspect of it, because I don't have to know the answers to everything. And if I, using those teacher resources, using this sample code, I can show the kids that yes, there is a way, and we're good. Okay. And then we have the scoreboard that I talked about earlier. So I can see my classroom, and I can see the different programs. We were in Cyber Robotics 101, and I can see how my students are doing. And here is the STEM Forward class. so I can see the ranking. So there's Cheryl, she's got 5 missions.
On
I can
top.
see you're on top, but not for long.
I know. Someone else gets the code, they pass me up.
Yeah, so we can kind of see how the different students are doing, how long they're spending in there, how many missions they're doing. And this is a fun thing that you can put up on the board so the kids can see it. And again, they can get excited about that, wanting to see, no, I just want to do one more mission so I can beat Cheryl, one more mission, a little more time. And again, like I said, this is one that a lot of times we'll have to actually kick people off off there to get them going there. So I'm gonna, oops, what have I got going here? Sorry, clicking out of there real quick. And the end of your classes and some other things. So then if they're doing the leagues, which we talked about the difference in the leagues, this is kind of what their screen would look like. So they can actually do the curriculum and the robotics league. So you can actually have both components of that, or you can do one or the other. You don't have to do both, but you can do both. And then again, down here, that knowledge base, that is just a really such a great thing to have available to you, those step-by-steps and then support. So one of the things that High Tech Kids is here for is we're here to help with getting things started, kind of those, whoops, this isn't working for me. What do I do now? And going from there. One of the newest aspects that they've just added is that students can actually share their code. And so the kids can write their code, they can download it and send it to you, the teacher, and you can actually upload it yourself and look and see, oh, their code is working. Or maybe that's where you can do some troubleshooting and saying, the student is saying, I can't figure it out, or I need some help. So you can kind of do that. But the teachers that have used it have really, they've liked that heat map, being able to see the progress of the students. And then, so I think that probably for us, Cheryl, we can share this information out, and then I think people can certainly get in there, start it, mess around with it. I will leave this classroom open for about 2 weeks so that people can take that opportunity, get in there as a student as they want to. And then if we have people that want to look at that teacher side, the best way to do that would be to contact me, and I can actually set you up as a co-teacher in this class, and then talk you through how to look at that and set that up. And we can share my contact information. Carrie, I believe you have that. And then so just contacting Jeannie at High Tech Kids, and we can either set you up as a co-teacher, or I can open it up. We can do a quick Zoom meeting and go through and look at it.